Okay, problem 12. Now this says find the values of x which the tangent line of the graph of the function is horizontal. Now as I say here, horizontal implies slope equals 0. So unlike problem 11, this is the only time they don't have to tell you the number, because the number horizontal will be 0. If it was some other number like the last problem, which was 6, you have to be told that was 6. Alright, so this time we're taking the derivative and then just setting it straight equal to 0. So easy polynomial derivative, 3x squared plus 8x minus 256. And that one's kind of, don't know if I would want one that difficult to try to factor apart there. It's a little challenging. I like the problem maybe, but it's a little tricky. It's 256, has a lot of numbers that go into it, especially considering I believe it's 2 to the 8th power, so it's got all kinds of factors for 2, but now you can also graph this and figure it out if you needed to. But let's see. So you have 3x squared, 3x plus 32, and x minus 8. So you're going to have negative 32 over 3 and positive 8, which that is not correct. That's what I was looking at there. I don't know why I circled that one. I hope the answer key has this correct as answer C. Yes, but that was not correct. Let's save this file now and convert it back to PDF. All right, now I solved it right, but I can't believe I circled the wrong thing there. So those two x values, this problem, unlike the last one, was asking for the xy point. It's just asking for the x only. Let's see what they've got down here. For this function, s equals t to the 4th tan t minus square root of t. All right, well, t to the 4th tan t would just be a product rule. Now you can choose either order of the product rule. However, when you're comparing it to answer choices, they might have done the other order, so you get to reverse your two terms, but that's not too difficult. I always tend to go f prime g as my starting rather than plus f g prime. So then using that, I would take the derivative of t to the 4th, which is 4t cubed, and then g would be tan t plus t to the 4th, which is your f, then times the derivative of tan, which is sec squared t. So obviously we have to know what the derivative of tangent is to solve this. So that's the part that's from the product rule. Now I didn't really show any work here, but I'll explain it. Square root of t is just t to the 1/2. So you do a power rule. So you bring the 1/2 down, and then 1/2 minus 1 makes negative 1/2. And then I didn't write the next step, but then the answer, see, has it written back. You know, this is correct, what I have, but if you drop the t, the negative 1/2 on the bottom, and put a square root on it, you're going to get answer A, that term. Alright, so looks like I left a step out there, but not a majorly complicated step. Number 14, quotient rule, so make sure you know this. Need that product and quotient rule throughout calculus. So this one is definitely more order specific because you have the minus right there between the two. That, obviously A plus B and B plus A are the same thing, but A minus B and B minus A aren't always the same thing. Only if A equals B. Alright, so it's the bottom, x squared plus 6x times the derivative of the top, which is 2x, minus the top, times the derivative of the bottom, which would be 2x plus 6 over the bottom squared. And this problem is extremely weird. I would not expect anything like this on the final. For this part where I'm factoring out this x, and I kind of regret that problem now, but because I've always had my quotient rule problems where whatever's on the bottom just stays there squared. You don't do anything. You never expand it out. But I did this because to match that answer, so I factor an x out of there like this, and you square both of them individually. So it's x squared, and it's x plus 6 squared. I would not expect this kind of weird situation to happen to you on the final. But this is good because it kind of directs you to the kind of question I could ask, but a little more, normal looking, um, which you can find from notes and quizzes and exams and stuff. So, okay. But anyway, let's go back to the numerator here. So we had to combine terms to get that numerator to simplify. Now, so you multiply this part, you'll get 2x cubed plus 12x squared. And then when you FOIL this, you're going to get 2x cubed plus 6x squared plus 10x, and 5 and 6 make 30. Now always be careful. Everything you have over here to the right is following that minus sign, so they all change signs in there. Whatever they are, they become the opposite. So in this case, these are all plus, so they now become minus. So the 2x cubed are going to cancel, and you're going to have a 12x squared minus a 6x squared, which gives you the 6x squared. And the negative makes that negative 10x, and this negative makes it negative 30. So there's your simplified answer, which is answer B. So let's look at number 15. Okay, now we're going to write an equation of a tangent line to the graph of, once again, you can see that's all smashed together, but you can see it fine on the original file. All right, so we have our function at the point x equals 0. Sometimes they'll give you both the x and the y. But remember, the way functions work, all you have to be given is the x, and then you can calculate the y, which is what I'll just jump ahead here for a minute to show you. Y would just be f of 0, so I'll put 0 in there. Gives you 2. So they could have just given the point 0, 2, but while they give us the x, that's all we really need. Now, so the equation of a line, we need a slope and a point. So slope is a tangent line. We know that means the slope comes from the derivative. So we have to get the derivative of this. Now this quotient rule derivative is a lot better than the problem before. Let's see, as far as it doesn't have that weird factoring stuff. So it's bottom, 4x minus 1 times the derivative of the top, which is negative 12x, minus the top, which is negative 6x squared minus 2, times the derivative of the bottom, which is 4, over 4x minus 1 squared. And then the tangent line slope will be the derivative at that value x. So we take the derivative of f, plug in 0. There was no point in simplifying this numerator really, because since we're just going to be putting a number in there, so I just left it like that. Put 0 in for x everywhere. Got negative 1, got 0, got negative 2, and the 4 stayed 4. So you end up with minus 8, which makes positive 8. And on the bottom, you're going to end up with negative 1 squared, which of course is positive 1. So you have 8 over 1, which is 8. That means using y equals mx plus b, we're going to have y equals 8x plus b. So we put in 0 for x, 2 for y that we got right here, and then we will get 2 for the b, just by coincidence. So the b will be 2, therefore your final answer will be y equals 8x plus 2. Okay, find the second derivative of this function at the value given, which is x equals 8. So you see I did this deal again like we did those other problems, wrote this 2x to the negative 1. And so the first derivative will be 8/3, and subtract 1 from the exponent will be negative 1/3. And that'll be, bring the negative 1 down, makes it negative 2x to negative 2. Now the second derivative. So it'll be negative 1/3 times 8/3, which will be negative 8 over 9. And then you subtract 1 from the exponent again, which gives you negative 1/3. Negative 1/3 minus 1 gives you negative 4/3, excuse me. And this derivative, negative 2 times negative 2 is positive 4. Subtract 1 makes negative 3. And then now we plug in 8. So you see I set it up right here, but of course I did it right over here in the calculator. And it works out to get an exact fractional answer. mainly because the cube root of 8 is 2, so it makes all these values become rational numbers. And it becomes negative 55 divided by 1152. Okay, number 17 gives us a function of an object traveling with some particle. Time for t is time in seconds. Find the velocity and the acceleration at the given time. So when it says velocity, that's implying at a single value, that's instantaneous velocity. Had they wanted average velocity, that's the same as the average rate of change that we did in one of those earlier problems. I'm not going to scroll back up and look for it, but if it was an average velocity, you have to be given 2x values. So it can't be average velocity of only 1x value. So this is the instantaneous velocity, which instantaneous rate of change is derivative. So long story short, to find the velocity of this particle, s, at 3, you need the first derivative, and then acceleration is always the second derivative. So it would be the second derivative at 3. So basically you're looking at s prime. I guess I could have indicated that this obviously is s double prime. V prime would be s double prime. So it's s prime of 3, s double prime of 3. So let's check my derivatives here. Negative 5t cubed would be negative 15t squared. 2t squared would be 4t. Negative 7t would be negative 7. Then the next derivative. So the derivative of negative 15t squared would be negative 30t. The derivative of 4t would be 4. So to get the velocity, I put 3 into this first derivative, calculator. You get negative 130. And put 3 in the second derivative, and you'll get negative 86. So those would be your two answers. I would not try to trick you as far as the unit measures go or whatever. I figure you have plenty of science and engineering classes to worry about the specific units. Okay. Number 18, find the derivative. Now we're getting into some chain rule issues. It's very important to be successful in calculus. All right, so we have f of x equals x cubed minus h to the 2/3. So we'll bring the 2/3 down, which I did right here. I subtract 1 from the exponent, so it's 2/3 minus 1 is negative 1/3. But very important to remember the derivative of the inside part. Think of it as u, that's your u prime right there. So basically it's like saying if you're taking u being a function of x, so if it's u to the n, it'll be nu to the n minus 1 right here, and then times u prime, or du dx. So must remember to take the derivative of that inside part. So which would be 3x squared, of course. So these 3's cancel, so you're left with a 2x squared, and you can drop that back down to the bottom. And they went ahead and made it a radical. You're just going with whatever your answer choice says. I wouldn't have cared personally, but they made it back into a radical. Perhaps it would just stay a positive exponent at the bottom, 1/3, who knows, but there we go. And so it would be answer D that is correct. Number 19. Okay, same thing here. So basically it's like u to the negative 4. So if you bring down negative 4, you leave the u alone. Students often make a mistake when they're first learning this of taking the derivative right here with that exponent, but they kind of jump the gun, but don't do anything there. It's still 1 plus sine of 7t here. Subtract 1 from the exponent. Negative 4 minus 1 is negative 5. And then you take the derivative of the inside. Now this is not an official mathematical term, but this is kind of the problem. I call these problems in class double chain rule in the sense that when you take the derivative of 1 plus sine of 7t, not only the 1, that'll be 0, but when you take the derivative of sine of t, that's not just cosine of 7t. That's a very, very common mistake for students to make. See, the derivative of sine of t would be sine of 7t would be cos of 7t, but it would also be the derivative of 7t, which is 7. Very important. Same thing when integrating too. That could be 1 over 7. Still, yes, you always, in the trig function, you always have to take the derivative of that argument right there. It's important. All right. There's a couple things to watch for here. So this one's challenging, but not unreasonable. All right, so let's see. I just kind of tidied up the -4 with the 7 to make -28. Seems reasonable. Combine all your loose numbers. Of course, I left the. So this is kind of weird. This problem just leaves the negative exponent as is, and it's answer choices, which is fine. That's what I would prefer anyway. And so leaves that as -5, and then so obviously we've taken care of that 7 now by combining it with the -4 for the -28. So, okay. And there we have it, all combined, and it matches perfectly with answer D. All right, number 20. Implicit differentiation. Now it doesn't tell us, 21 tells us implicit, this doesn't tell us implicit, but it's obviously, implicit means that y is not written as a function of x, basically. It means x's and y's are, explicit means where y is a function of x. Implicit means your x's and y's are all mixed together. Okay, so remember the rule on this is that anytime you take the derivative of a y term, you have to put a y prime with it. So the idea we have to remember to do that, and then once we do that, then we keep all the y prime terms on one side and the non-y prime terms on the other, so we can factor out the y prime. And then that's, so these answers always look kind of messy, but they're not that bad. Well, they can be, but nothing I would ask would be too outrageous. But this one's at the point 1, 1, so we're going to get a numerical answer. But let's look at this here. So the derivative of 3y cubed will be 3y squared, because we're taking the derivative of y, put y prime there. Now, when you have x and y multiplied together, that is the product rule. So I'll go F in my usual order, F prime first. So the derivative of y would be 1, but it's 1y prime. You have to put y prime there. Okay, the x squared is the g, plus the y itself times the derivative of x squared. But when you take the derivative of an x term, you don't do anything special. So the derivative of x squared will just be 2x. Plus here, the derivative of x squared again will just be 2x. And the derivative of minus 3y squared will be -6y. And then because we differentiated a y, we put y prime. Now, okay, the next step then, and then equals 0, of course. The derivative of 0 would be 0. So I kept the y prime terms on the left, and I moved the non-y prime terms to the right. So 2x comes the other side to -2x, and then the 2xy becomes -2xy. And then you see I factored out a y prime. That's why I want all the y prime terms together, so I can factor it out. Then I've got 3y squared plus x squared minus 6y. Factor it out of there, leave the right side alone. And then you divide both sides by what's in your parentheses. So you have, so now that becomes, the parentheses becomes the denominator. Now one thing to keep in mind when doing implicit differentiation, especially if you're trying to match an answer in a multiple choice test, is that they might have done it differently where they have their y primes on the other side, the right side. They don't have to always be on the left side. Well, the way to tell is, well, you could always move the terms over if you wanted to and check your answer, but an equivalent answer to this would be if you multiply top and bottom by -1. So what would have happened is these two terms would have been plus, it would have been minus 3y squared minus x squared plus 6y. So if you're doing an implicit differentiation problem and you're pretty sure you did it correctly, and you see an answer choice that has every sign, every term has the opposite sign of your answer, that means you're right, and you want to pick that answer. It just means they put their y primes on the other side. So if it's the complete opposite, they're really equal, because like multiplying by -1/1. So now you have this, and you put the 1 in for x, 1 in for y, 1 in there, and you end up with -4 over -2. If you put it in here, you get 2. So that will be the slope of that graph. There's another one we're going to get the algebraic answer. And this looks like this is what happened to me on this one. This is what's happening, what I was just talking about. All right, so we got to do a product rule here for 2xy. So we're going to have to I'm leaving the 2 with the x. But it's better than leaving it factored out than having it distributed. So the derivative of 2x is 2. And then y will just be y plus 2x. So there's the 2x, and the derivative of y would just be 1y prime. And then minus the derivative of y squared, which is 2y, y prime. And then derivative of 1 would be 0. So you see I'm leaving my y primes on the left. And so I factor it out, it leaves me 2x minus 2y. And then you move the 2y over, makes that negative. And so you have negative 2y over 2x minus 2y. Now notice, don't get too cute here. And this one does reduce. Maybe the one on the bottom won't reduce, but every term, you can't just reduce part of it, top and bottom. So keep that in mind. This only reduces because there's a 2 everywhere. Every term has it, so it's factored out. Like if 2 of these had a 2 and one of them didn't, we couldn't do anything. So you have negative y over x minus y, which you go up here and look, and that doesn't match any of my answers. So, oh no, maybe I'm wrong. Well, here's what I did. I multiplied by -1 over -1 to see what would happen. Now I did rearrange terms down here, but so that makes that positive y. Then on the bottom, yes, that would be negative x plus y, which negative x plus y is the same thing as y minus x. So then that's how it matches y over y minus x. 22 is a related rate problem. And that's a little bit different. This time, every time we differentiate any variable, we put d something dt here. So, okay, circular area equals pi r squared. And so first thing I'm going to do is get what's called the related rate equation. That means taking the derivative, then we'll decide what we're solving for. Okay, so if a equals pi r squared, of course pi is a constant, so derivative of a would be dA dt, and the derivative of this would be 2 pi r and then dr dt. Now there's 3 variables here, dA dt, r, dr dt, so that means we've got to have enough information for 2 of them and see which one we're solving for. You never assume that you're solving for the left side every time. In fact, there's 2 ways you can tell. One of them, they're giving us the area, the rate of the area changing, so they're giving us dA dt. But also the question says how fast is the radius expanding? Okay, so that would be dr dt. So they're actually asking for this variable on the right when the radius is 171. So once you get that set up, it's not too difficult. So we never assume it's always just the right side. Okay, so we put 8 in for dA dt, that's our rate of change of area. 2 pi, then 171 is our radius value. And then dr dt is what we're solving for. So it ends up being 8 divided by all that mass right there. Now notice how I kept that in parentheses in the calculator, very important. So if you want 8 divided by all of that stuff, you need all that stuff to be in parentheses. And it matches letter C, 0.0075.